Hello. Hello. Is my voice is audible? Okay. So, good evening, everybody. Today, I am going to explain about the Xilinx software. So, actually, I have the all screenshots of the software that I will share with you. Today, I am not getting the share option here. That's why I am checking where it is. Mm, okay. Already, as per our schedule, up to that, whatever we studied, the VHDL program and the sequential and combinational circuits, everything we are going to design in the Xilinx software. So in the Xilinx software, we have to write the code here to implement your programming. That is either in the form of VHDL or Verilog. So directly you can write a program. Here, what is the advantage of using this Xilinx software means? First of all, I will tell the basic here. So I told that this is called simulation ISC simulator. In the ISC simulator, if you opened now you see the Xilinx window, and also another software also available, that is the Vivado software. In that software also you can do the Verilog and VHDL coding. Okay, so whatever I explained yesterday, VHDL coding directly you can write by opening the new file and you can simulate. Simulate is the one form of output, and another one is that FPGA kit. By using the FPGA kit also yesterday I told that the combination logic block and IO blocks, switches, tracks, routing, placing, everything I told, that is whole kit available in the market. Different types of versions of FPGA kits are available, that you can copy the program in the FPGA and simulate by giving the number of inputs and the number to check the number of outputs according to your program. Okay, so two types of simulations we can see here. One is the in the form of waveforms. Okay, day before yesterday I shown that the waveforms of the combinational and sequential circuits for the 00 how it is mentioned in the output. Likewise, it is displaying in the your software. Okay, so now here as per our VHDL coding, we wrote that entity and architecture. The main functions are entity and architecture. So in the entity, what we did here, in the entity we mentioned that input and output ports. In the architecture we mentioned that functionality. It means you have to write the function, how it has to work, the total number of inputs and total number of outputs. Okay, so here what we are doing means, in this Xilinx software, whenever you open the new window, okay, so before going to write a code, you have to select that which type of code you want to write. Suppose I am going to write a VHDL code. That VHDL you have to select. After selecting, it is asking to the number of input ports and number of output ports. Okay, suppose I am taking the AND gate, two inputs and one output. Okay, so AB is the input, Y is the output. Okay, you have to mention A, and there is a button that if you press the button, it shows that in and out. So whether A is the in, that is you can select, and second one B is in, you can select. Second and third one is Y is out, that you have to select out. So by selecting these inputs and outputs, whenever you enter these three terms and click on OK, automatically in your program window, the total program it is generating. It means library IEEE it is generating automatically. Okay, standard underscore logic 1164 dot all it is also generating. You no need to write. And the entity also it is generating. Architecture also it is generating automatically. That is the main fetching of Xilinx. So why? Because you already mentioned that how many number of inputs and how many number of outputs. Okay, that A is the input, B is the input, Y is the output. So you mentioned automatically it came into the entity port. But in the architecture, the format it is coming. It means architecture name of entity and architecture name. These two will be available. In between, you have to begin your syntax. Why? What is the syntax here? Y less than or equal to A and B. Y less than or equal to A or B. Y less than or equal to A and B. Y less than or equal to A or B. This architecture syntax you have to write. That's all. If you write that instruction in between the architecture body, then you can execute. Now here, you think that you are not writing all program here by giving the ports itself. The total body structure of the program it came. In the architecture, you can mention that syntax, and also you can write the test bench. Suppose you are mentioning that y less than or equal to A and B, but I am mentioning that just like a data flow. If I am taking the data flow modeling, in the data flow modeling, I am mentioning that if A is equal to 0, B is equal to 0, then Y is equal to 0. Else, A is equal to 0, B is equal to 1, Y is equal to 0. Else, A is equal to 0, B is equal to 0, Y is equal to 0. Else, A is equal to 1, B is equal to 1, and Y is equal to 1. This is the end gate test bench I written. So, likewise also you can write. This is called test bench. For this small program, you think that it is very big instructions you are writing. But if you go for the big architecture, you have to write the data flow test bench to verify the big circuitry. For this circuitry, already the gates are available, AND gate, OR gate, that you can simulate. But for the 8x1 multiplexer by using the 4 2x1 multiplexer, if you want to design, for that we have to write the test bench. Without test bench also we can write it. But if the more complexity increases, then automatically errors is going to be increased. To avoid that error, we have to write the test bench. So now you tell that I am going to write the encoder program. Encoder program is nothing but a 8x3 encoder, mostly we are discussing. So 2 to the power of n inputs and n outputs. So here in the program, in the Xilinx software, I am giving that A, B, C, D, E, F, G, H is the input and X, Y, Z is the output. If you mention like that, what happens? Total program will come, but architecture you have to mention. Architecture, what you have to mention? If XYZ is equal to 0, 0, 0, then Y is equal to 8 zeros. Next, if X is equal to Y, XYZ is equal to 0, 0, 1, then Y is equal to 0, 0, 0, 7 zeros and then 1, 1. Likewise, the 1 is generating diagonally. You already know that. 1 is generating diagonally in the truth table. Likewise, if X is equal to Y is equal to Z is equal to 1, all ones, that time Y is equal to all ones. Likewise, all ones, sometimes you can write all ones, or otherwise sometimes you can take it as the first bit is 1, remaining and all 0. That you have to, according to the design in the logic diagram. Okay, so if you are designing, if you have to write the test bench and you can verify. So all programs we are going to verify like this only. So nothing in this Xilinx software. In the Xilinx software, you have to learn the step by step how to write a program, how to simulate a program. At the same time, if you know the Verilog program, starting itself, you have to select the Verilog and you can write a program. Okay, so this is the concept here. Okay, so I think it is very clearly audible. I think so. Likewise, your program you can write for the all those. Okay, so and in this writing software, I told that there is a B is the inputs. So the same program, if you want to implement in the field programmable gated array, that time you have to mention the pins P1, P2, and P3. P1, P2 as the input, P3 as the output. This is the UCF file. This file you have to generate to know that the FPGA kit, what are the inputs and what are the outputs. Then you can check. That is another type of output. And also, you can do the projects in the Xilinx software. So, how you can do the project? So I will tell the one journal paper. So I am explaining in the research oriented and application oriented that is useful to continue your core jobs. Okay. So if I am going to give the one example, FPGA implementation of MMS transceiver using CDMA or GSM. Okay, so FPGA implementation means the all Verilog coding or VHDL coding you are going to implement in the FPGA and you are going to show in the diagram. It means now in the lab oriented programs you are going to show the result in the FPGA kit, but in the project oriented the directly IC you are going to create in the FPGA. So here FPGA implementation of MMS. MMS means multimedia service. Multimedia service means what? Our images. Whatever now we are transmitting using WhatsApp images, videos, that and all coming under this multimedia message service. Okay. These we are going to send and receive. So our mobile is the full duplex. Full duplex means what here? Full duplex means it is receiving and transmitting at a time. So if we speak now, that also it can transmit. So both we can speak parallelly. That is called a full duplex. So this is we are going to implement in the CDMA and GSM. So what is the difference between CDMA and GSM? CDMA means the frequency is fixed for particular. So sorry, CDMA is the frequency is fixed for the particular user. But in the GSM, if the more number of users are increases, automatically the frequency is going to divide. Suppose 100 hedges I am using, 10 users under this 100 hedges, then the for 10 hedges that is called GSM. So 10 hedges for the first person, second 11 to 20 hedges for the second person, 21 to 30 hedges for the third person. But in the CDMA, 50 hedges is allotted to you. That is fixed to you. You can't change your frequency. Okay. So if you are utilizing or not that frequency, it has to fix it to your mobile. Who is fixing? That is another one. That is it has to write a program. That is depends upon your handset. Okay. So now I am going to tell this application. This application how we are implementing in the FPGA means before that you have to know about the transceiver. Transceiver means a transmitter and a receiver. Okay. So here the mobile station is nothing but your handset. From this you are going to transmit the data. Now I am speaking, you are listening is nothing but it is very fast transmitting the data and also storing also. Okay, so from the mobile station to the base station. Base station means that is nearer to your mobile. There is a cell tower. That cell tower we will call it as the base station. So from the station to again it is connected to the satellite. From the satellite to again it is connected to the other side person. Those who you are going to send a message or a call. That person base station it is connecting from the base station to another user too, like this. So if there is a far distance, that time what happened, the number of base stations it is increasing. Okay, so now you are moving automatically, the base station it is going to change. So this is all happen in this network, it has to implement in the FPGA. So this network you have to implement in the FPGA. That is the concept here. So now what we have to design here, trans receiver we have to design. Trans receiver means what? Transmitter and the receiver. So transmitter means what here? It is going to transmit the electromagnetic waves from the handset. How you are going to generate? There is a master IC, it is available. That is, we will call it as the master. It means master chip. In this master chip, the all gates, whatever the gates are supporting to your application, that you have to write in the Verilog code. That master you have to show, and the supporting registers, memories, and the clocks, everything we have to design. If you want to design any transmitter or any device, you have to give the clock and at the same time the crystal oscillator and at the same time the frequency it has to measure. Okay, and the receiver side it is going to receive the signal. Okay, so transmitter block, receiver block, you are going to design in the FPGA. So what are the blocks present into the transmitter means? What are the blocks it is presented? Amplitude modulation. Okay, frequency modulation. So amplitude modulation, frequency modulation, by using these two modulation techniques, you are going to transmit your signal. So who will do this? There is a modulation block is available. Okay, these blocks you have to design. So modulation means inside there is a diodes and the transistors you are using to transmit this modulation. So the transistors in nothing but again it will go for the logical design. So this and all you are going to design and give the inputs. Here the number of inputs it is going to be increased. So according to that you can design the transmitter. Receiver is very important here. Receiver it has to arrange design with respect to the frequency. So these and all blocks we have to implement in the Xilinx software, and you have to write the code for the each functionality, input ports, output ports, and the architecture. Everything we have to mention and dump the program in the FPGA. Then you can see the result in the FPGA kit in the form of LEDs. And also the same output you can see in the form of simulation in the screen. It means the waveforms it is going to generate. So that is our main project we are going to design. So 1 minute. Hello, all are following. Is my voice is audible?